what we'd like to do is to do these tasks, which is based on the files that were given to you. I'd like you to just make some modifications just to be able to play with it. But later on, I just like to finish this and then make sure that you understand all what these other class, SLL class, is doing. Now, these are all the files. So basically, this is the one that tests the integer. So what we'd like to do basically in this first one is just simply change this from an int to a double. So as I showed you earlier, just Control C, Control V. But when you do Control V, you can just do it on the same place, or just make sure if you'd like to have it on another package. If you want to, you can, but it doesn't need to. Now this is going to be asking you what's the new name of this new class that you copy class, and just make it double, and then click refactor, and it's going to be now a new class called test double SLL. So I'm going to remove this, basically make the change to everything that is integer. I'm going to do Control F, or Control H. Control H allowed me to do some kind of find and replace. So I'm going to find integer, and then I'm going to replace it with double. That's much simpler than trying to do it manually, because you might forget some of them. So what I'm going to do, I'm going to click on this replace, not replace all, because I'd like to see each one of them that is going to be replaced before I replace it, just to make sure. Now the first one is selected, so if I click replace, this one is going to be replaced, and selects the next one, I'm going to replace it. Or basically, in this one I can just remove it, but let's just replace it for now. Now this one also needs to be replaced. Okay, yes. And then the result here, the note to delete, for example, it's not now an int, it should be a double, so I'm going to replace this one as well. And you see the target now is a problem, but still no problem. Let me see do I have another one? No, I don't have any. But now I have a problem. Once I did this, let me just close now. I have these lines here. It shows me that there are some problems, because I cannot now add the ints. But I made them double. Why is it complaining? Because the add to head takes a double, and it's not an int. Now to fix this, I need to have int. But I would just like you to realize that because this is a class data type, the integer and the double are not automatically converted, as you have noticed. Because normally if I put an int into a double, if it was primitive data type, it's fine. But this is not okay, because this is an int, the primitive data type, that is trying to be converted to a double, the class data type, which is not okay. So that's why this is reporting as a problem. Now I'm going just to change this to double, and it should be fine. So next double as well here, and this is how I can fix my problem. So just click on the red dots here, or red lines. It takes me to where the problem is. Now here the same thing is next double, and the target here, I need to find its declaration, it's C, and to do that I just press on the control key and then click on it. It will just take me whatever it was declared, and you see this is a good help that I get from NetBeans. But however, I cannot make this to be double because of the switch. The switch accepts only int, so I need just to split those two. One of them is going to be double, the other one is going to be int, stays as int. And it seems like I don't have any red dots or lines. That means it should be fine. So that's a small way how to fix it. Now I'm going to click on save, and then whatever. So because of these comments probably. Now I don't want to have a look at all of these, but except like this one. You see, this is just delete from head. It just removes the one from head. I'm going to look at those details later, but for now I just would like to make sure that I just do whatever it needs to do. Just simple things. Now if I try it, I run it. Now this works with integer because of when I run. Look, notice one thing. Let me just close this. If I run by default, it's going to open the ones with the integer. Why? Well, This is where the main, but don't I have a main here? I do have a main here. Because, well, normally if I would like to run this one, I can just right click and then run the file, which I don't have it. I don't know why this static void main, and it doesn't want to be detected. You see this one? This symbol here means there's a main in this class. Here it doesn't show me that. I don't know why. It seems like maybe it's a bug. Let me just close it and open it again, because it doesn't make sense. Let me close it and let me open it. Lab 1 again, open, and I hope now that I'm going to see it, but see, I cannot see it. Interesting. Now that's something. Why is it like that? Allahu alam. I have no idea why this is like this, but it doesn't. It seems to be a problem, but I'm not going to be. There's something wrong? No, there's nothing. Oh, there's something wrong. Wait, this is the one that just ran. I need to close it. Let's try press 8 and then it stops. How about this one? Yes, 8 and then stop. Was it this one that prevents? No. There's a main method, but I cannot use it. Anyways, I'm just trying to say something. Now, when you set up this, the first time it just remembers which main was to use. For example, it doesn't run this one, even though there are two. Because if you right click here on the project, you go to project properties, you're going to be seeing that this in the run here, it tells you this is the class to run. If I want to change this, I can. And now it seems the double is available, but I don't know why I cannot see it here. Anyways, so I'm going to select this to be my main class now. Now this shows that this is my main class now. Every time I click on this button, this is the one that is going to be run, even though it's not showing this symbol, whatever. So if I run, you see it says now with doubles. And now if I add to the head, let's say add to the head, I'm going to add 2. If I display now, press 3 to display, I'm going to see that this is 2.0 because it's a double. If I add to the head again, no, 2 now adds to the tail, so I'm adding to the tail until the element to add to the tail. Let's add 1. So now it's going to be, if I display with 3, 3 is going to print all nodes. So if I display them, it's 2 and then 1. If I add to the tail again, and I'm adding number 3, and I display now, all of them say 2, 1, 3. If I delete from the head, that means the 2 is going to be gone. So if I delete from the head, that means choose choice number 4, and then display, the 2 is gone. If I delete from the tail, choosing the 5, the 3 is gone now. So I only have 1. So this is showing me that it works. If I delete a given node, like for example number 6, I'd like to delete the node number that has the value 5. And if I display, there's no one that has value 5. But what if I have, for example, I just would like to add some, I'm going to add some elements here. Now if I display, this is my list, 4, 3, 2, 1. Now if I'd like to delete a given node, and I give it the node 3, for example, the value is going to be 3, and if I display, the value 3 is going to be found and then deleted. And if I give something that doesn't exist, nothing is going to happen. So nothing is going to be deleted. If I search for a specific node, if it exists or not, for example, if I search now, I'd like to see if 3 is available, it tells me, sorry, the element 3 is not in the list. But if I try it again with something that is in the list, it will tell me the element 4 is in the list. So it's basically the basic operations. I can have more operations if I want. Like for example, tell me how many elements do I have in my list. So it will just count the number of, tell me how many elements do I have. So it tells me 5 elements or 10 or whatever. So if I'd like to do that, basically, if this was one of your questions, what should you do? No. I'll just just copy this print all, because count made a lot. I need to add, whenever I add the plus plus, whenever, I don't need to do that. For example, I can just copy this, and instead of saying print all, I'm going to say how many print number of elements. Oh no, of elements, for example. And then when I'm doing something like this, I'm not going to print anything. I'm just going to increment some variable that I'm going to declare. I start from 0 and I increment it, and once I finish, because that means I've finished, I've went through all the elements, I just display the number of elements is, or maybe there are, there are count elements in the list. That's much simpler than having to have the count in the count plus plus. There's too many modifications. Plus, I'm going to add an extra variable to the class, which is going to cost more in terms of the space, because every variable takes some space. And so this is going to be calculated once I need it. Now what I can do, just maybe add another one that is going to be, now instead of 8 to be that, let me just copy and paste and make this to be 9 to quit, and then here to show the number of elements. And of course I need just to make small changes, and the do while need to be also changed, because now case 9 is going to be my lead, and I need to also to add something here to have the case 8, and I don't need to do anything. I just need to display, to call this list dot show, was it in print number of elements. Let's run it to see it works. Now if I'm just going to type now just 8 just to see, there are 0 elements in the list, which is correct. Now if I add one to the head, whatever, and add another one to the head, if I display them, there are 3 and 2. Now if I type the 8, there are 2 elements in the list, which is correct. So anyways, you can play with it. There's a lot of things that we can do. That's what I mean with play with it. Just try it. Okay, what if I'd like to do this? Try it and see what could happen, and then experiment. You might spend some time trying to find something, how it works, but then it's worth it, because you're going to be understanding more how these things work. Okay, now that was the first part, which is very easy. Now the second part is write a class student consisting of data fields, ID, name, and GPA. The class should have 3 constructors, one that takes only ID, one that takes ID and name, and one that takes all the 3 fields. Finally, the class should have equals and 2 string methods. Note the 2 string must return only the field values separated by the tab character, without field names. That means without the ID, name, and GPA. And then save. Now this is the new class that I'm going to create, so I will do that. And just to do that, I'm going to create it in the same place. I don't need to have a new package. Yes? No, we don't have to. If we want to, we could, but we don't have to have a default constructor. But at least if we don't have one, Java is going to give us one. But here in this case, for example, hold on. In this case, it asks us to have 3 constructors, one that takes 1, one that takes 2, one that takes 3. There's no one that's going to take 0. So it's just the design of the class, who's the one who decides. But for convenience, it's better to have one that takes nothing. But anyways, because now they don't want to have, so that's fine. So let's have a new student. And I'd like to also, for those who were not using NetBeans a lot, I'm going to like to show you how NetBeans can help you a lot in your programming. Now, this class student, I'd like to have, I said ID, name, and GPA. So the ID is going to be int, the name string, the GPA double. And I did not put them as private because I could, because there's nothing that is needed. Why would I? Normally I should always put them as private. Whenever you declare something in the class, by default it should be private. And if you need a a getter or setter or no, then you can to have that. Initially I thought maybe I will have to have those setters and getters, but it seems like we don't need one, so that's why I did not do that. But if I needed one, I don't need to have this private typed by myself. I can just have this insert source code, or is it like source insert code? Yes, something like this. Insert code here. Or if I just press the alt insert, which is exactly doing the same thing, it's going to show me this. So source insert code is going to show you the same thing again, and then you can decide to have getters and setters. And here, for example, if you select them all, it's going to create a getter and setter for each one of them, and clicking on encapsulate fields will make them private. So that's why I did not put them private myself, because I was thinking I was going to create those getters and setters, but since we don't need them, so all I can just type the private myself. Now for the constructors, something convenient is this insert code or alt insert, as you can see from here, the alt insert. Now if I would like to insert a constructor, I'm going to insert a constructor that takes 1, and do the other one that takes 2, the ID and the name as it was required, and the last one that takes all of them. Alt insert again, and then all of them. So here you go. Without typing any line of code, you just generated all the 3 constructors that were meant. So learn how to use NetBeans, because it's going to help you in your programming. It's going to shorten your time you type things, and it's going to be better for you. Now finally, the class should have equals and the toString. Even those 2, I can generate some of them. At least the one, like, sorry, not alt I, it's alt insert. Now you see I can have the equals and toString. Now equals and toString, equals first, it has something that comes with it. It's hash code. I don't want to talk about it, but I'm just looking here at the equals. What will make 2 student equal? I need to check. Is this like they should have the same ID and the same name and the same GPA, or maybe just the same ID and name, that's enough? So it's up to me to decide what it is, because nothing was mentioned here that tells me what the equals should give me, right? So I can select whatever I want. Now I'm going to select them all because I want to, but I could just select only 2 and that will be enough. I'm going to select 2, let's say. Now for this other one, I don't care. I don't want to talk about it. This is for some other things. This is some kind of a code that is going to be generated. As if you click on it, it's going to have this hash code generated for you. You can just also remove it. For us now, it doesn't matter. But this is what I get. And this is better than any other. I could have done something like this to be closer to what we have somewhere, but this is a more complete and better one. Why? Well, I don't want to talk about it. Let me talk about it another time, because I don't want to complete. Because this is Java 2 basically. I don't want to spend some time there, because it's about this upcasting, downcasting, and just to make sure that first of all this is not null, for example, and if it's the same object, why should I just keep going? So it's more complete way how to check. If this is creating some problems for you, especially this thing, just forget about it. But this is the main part. So whatever this object was given to us, I'm going to convert it to downcast it to a student, and then I'm going to compare. If the ID is the same, then the other ID. If this ID same as the other ID, then sorry, this is not going to be true. So I'm going to continue. If this name, well, this is I can just use something different. I can use this, and then dot, because it was generated, so that's why it came out like that, equals the other one. So if this name is equal to the other name, then not this is going to be false. So I'm not going to get in. Anyways, so it's going to check one by one, and then I can just put them, maybe all of them at once, and say if this is, but the idea is that it checks one condition at a time. If one condition fails, it just gets out. But what I can do, I can just simplify this to just something like this. But this is not the best code, but it's going to work. And I'm going to ask, for example, if this is, for example, if this is different, is okay, maybe I'm going to do something like this. If this is different than the other one, and this one is not equal to the other one, then I'm going to return false, else return true. Or I can put an else here, so it will make it even clearer. So I'm returning either true or false. So if this is then, let's say, or maybe I can swap them. If they're equal and they're equal, so I don't need to put this, then return true, else return false. Basically, I'm just showing a different way to do the exact same thing. But which one is the easiest for you? This is the one that you're going to use. Use whatever it's easiest for you. Now this is something that assumes that the object that I'm giving is a student. What if I'm not giving a student? I'm giving a table or a rectangle as a class. This is going to raise an exception. So that's why there was a lot of different type of codes that were given to us by default by NetBeans, because they do this verification that basically, hold on, let me just go back to make sure that, for example, this is like some kind of a class that can be a subclass of that, so it's not something that I'm going to be able to do to avoid having some problems when I do this downcasting. Because you remember from Java 2 that upcasting is kind of easier than downcasting, because downcasting you have to make sure that actually you're converting an object to be a student, and that's what's inside of that object is a student indeed, not another class. Yes. Yes, instance of, that's another operator you can use. Yes. Yes, true. So instance of and get class are, there's a difference that now I don't recall. There's a difference between the two, but yes, you could use that. So that's the equals. What it does, it just basically makes sure that if it's the same thing, I'm comparing the same object with itself. If this is equal to the object given to me, so of course they're going to be equal. If not, then make sure they're not this is not null. If it's null, of course there's nothing, it's not going to be equal. And if it's not a subclass, then this downcasting is not going to work, so they're not going to be equal. Then this is going to be, it's not even a subclass, it's the class itself. If this class is not the same as the class, so they're not going to be equal. Now, if knowing that they're the same, I can do this. And remember the final, what it does, right? Final is doing what? It can change. Why would I change it anyways? But just to make sure that you don't do something weird, you made it final. That's why that's safer. And then it checks if these are different, then it's going to be false. No need to keep checking. But if they are not different, then okay, keep checking about the names, if the names are equal. If I had also checked the GPA, I will have another line for the GPA, another F for the GPA. If I want to have one, I could do something like this also for the GPA, and this is going to be like if the GPA is different from the other GPA, then return false. Else, I'm going to return true. So if all these are failing, that means they're the same, so I'm going to return true. So now this is our class student. We had these three instance variables, those three constructors. These equal, it took us some time. Now the toString, I need to have toString so I can be able to display the content. So now the toString, let's do it again, and this is same thing Okay, that's the proxy kicking in. Now I'm going to also insert the toString. So it's going to place whatever I want. It tells me what you would like to display. I'm going to display ID, name, and GPA. Okay, generate. But I don't want to see these. Also, no, I don't want to see this. I'll just see the ID, and then put a space, and then the name, and then put a space, and then GPA, and I don't need the rest. And that's it. Yes. Oh yes, sir. Very good. Because yeah, it mentioned tab by tab character. So a tab is \t, and just copy and paste it here. You're right. Thank you. And I'm done with this one. So it's going to display something like this, whatever, like this. So now, this is my student. I would like to change this test item to test students, so I can work with students now. I'm going to basically do the same thing and copy this, Control C, Control V, and then change this to test student and refactor. Now I'm going to do the same thing here. Control H is going to bring this find and replace. I'm finding item, I'm going to replace it with student. And let's go. Now this is replace this one, then the next one, then with items, and now I'm going to have items. So of course every item is going to be replaced with the student until the name of the item. There's something that I will have to change, but anyways, just keep going. Now item is going to be changed by student, and then again keep doing it. Student instead of item. Student was not found, and I think that's it because there's no more thing to replace. Let's close and try to fix the problems. So this first one is that enter the item name. Now it's going to be the student name, and there's no student price. It's going to be student GPA, and I need one of them, one extra for the ID. Yes, thank you. I was thinking about this next, which is the ID, and I don't have this ID because these were declared here, and I'm going just to rename. You see, click here, rename it to, I'm going to call it GPA, and with the option I can add another one with the ID. And if I go back to there, now list add new student, there's no just one that takes the name and GPA, so I can have, I just need to add the ID for that. So this one, create a new node to the head with all of this information. I'm going to copy and paste basically, but these are all the same, but fine. All I need to do now is just have the same ID, and that's it. ID and GPA, and then so now enter the name of the student to delete. So this gives me the name, and then this has declares a new student. But now I have a problem. There is no constructor that takes only the name, because now if I'd like to find a student to delete, because this number 6 is going to try to find a node by its name. Now doing so, well, I'm going to just create a new object. I can just maybe instead of this by name to make it now maybe by ID. It will be easier because
even in practice he said all these three constructors, so we have to change it.
What do you mean?
Here he said one constructor with ID only, one ID and name.
Yeah. So we have three constructors, one with only the ID, one the ID name.
Have the ID.
Well, it depends. Let me see. No, okay. There's nothing that mentioned. Nothing is mentioned. Basically, saying how we should do things. Except maybe do we have something that tells us? No, not really. Okay. Let's delete a node by its ID then. Now, if I say a node by instead of a node, maybe. Okay, just go ahead and delete a student. Makes more sense. Okay, let's keep it as a node. Not a big deal. Okay, so delete a node by its ID. Now I have this ID thing that I need to put in the case number 6. So instead of having written a name, I'm going to read the ID and next int. So once I have the ID, I'm going to initialize a new object and then sorry, and then I can just put the ID not found, so it was found. But look, there's something that's going to happen. I'm sending a new object, student, with only the ID to be initialized to the delete. Now this delete is going to try to see if the information is equal to this one. Now which means this is going to call this equals here to compare between the student that has only the ID, no name, no GPA, and the one that has exactly the same ID but with the name and GPA. Now based on this equals, all these three should be equal. So even if the ID exists in my list, it's not going to be deleted, because this equal is not going to be considering the two equals, because we need also to compare the name and the GPA, which we don't have when we are searching. So what I'm going to do to make it work, I'm just going to compare only the ID. This is the only thing that I need to do to compare between two students to decide that they are equal or not. This will now make this work, because I'm just checking only the ID and I don't check the name, then this is going to work. If I want to keep them, I need to, instead of just asking give us only the ID, give us not only the ID, sorry, I give the ID. I'm going to ask them, give me the ID, the name, and the GPA. Then I'm going to be able to delete. So in order for the convenience of only the ID, I'm just going to remove those and keep only the ID as my way how to know if they are equal or not. If they have the same ID, they are equal. So that's what I'm going to do to make this work. Now this result, okay, the result has been deleted, okay, and enter this. I'm going to do the same thing here, because what is the number 7 do? 7 is just searching for the node, which basically is the same thing as the number 6. So I'm just going to copy this thing. The first 3 are all the same, and okay, not delete, sorry, I need to find. Instead of, it's exactly the same thing. Yeah, and then I'm just going to change the name to ID. It's going to be faster. And here, ID, and just this int and ID. So the item was found, or a student was not found, and that's what I'm going to keep. Alright, and let's run. Before I run, because I would like to run this one with the student, you see again I have the same problem that I don't know why. Normally you can run the file. You see, you right click on this one and you can say run file, so it's going to run this file with the students. But if you click on this one, it's still going to run the one with the doubles. So if you're fed up with running the doubles, you just go to properties, click here and then browse, and then test students. Okay, I think there's a faster way. Maybe there's a way to make it something like that, to be always there, make it default or something, but I don't see it. No, there might be a way, but I'm not aware of. Anyways, so now if I click on this run, and there are 2 running already, I'm just going to close them. This is my 9 and this is 8 and this is 9 again. Okay, so I don't have them running. If I click on run now, okay, now this is the one that has a student. Let's click to add one to the head. So please enter the student ID, that's student 1, name 1, and then GPA 1, just to have them. Let me display them. If I display them, what is going to happen? You see this SLL, sorry, this single linked list. What it's going to do is you're going to print the info. Well, what is the info? The info is a student. So this means it's going to display, called the toString of a student is going to display the toString. Like if I, okay, now I don't need to run this one because it's already running. Just go back to here. Now if I click 3, what I'm going to see this is the first student with the, like this, ID, name, and GPA. Now if I'm adding to the tail, let's say I'm going to add another one, which is ID 2, name 2, and GPA 2. And I'm going to display them. So this is what I'm going to see. This is the 1, and then this is the 2. Now it's not going to show clearly because, as you can see, there's just one space between them. If I want them to show up maybe better, I just need to find this print node, print all, and then instead of this I can put, for example, a more clear space, or maybe like this one. Like I put the space before, space after, and then this horizontal bar. Sorry?
We want to
Backslash anyway. I don't want them to be on the next to the line. It's going to be, well, we could, yes. We could do \n. I just want them to be on the line. But then if I want to do \n, I could just do println. Now I changed that so it will just display them in a different way. Maybe what I could do also before that, let me just stop this. It's much. I could just do print all because I don't like the way it does. I can just do something like this to show me where the list starts and where the list ends, so it doesn't get confusing with all the display of this thing. Now, for example, if I display it, let's say 3 and there's nothing, this is empty. Okay, if I add 1, now this ID is 1 and 1, and then 1 for the GPA. Let's add to the tail again. This is 2. N2, and then the 2 as the GPA. If I display them now, I'm going to see this before and this after, and this is the first one, this is the second one. Now if I'd like to delete a node by its ID, and what I'm going to do, well, now I'm running, I don't know if I can make a change, I think. Now let me bring back this. Now I'm putting all these conditions back so you can see that if I'm trying to delete by the ID and then in my equals I'm checking the ID, the name, and the ID and something else, basically, it's not going to work. And this is what I hope it's going to show me. So let's delete by its ID. I'm going to choose the number 6, and what's ID is number 1. It tells me 1 has been deleted. Really? That's nice. Let's see if I'm going to display. It has been deleted. So what happened? I'm going to check the code because I'm not sure if maybe I'm not sure if my change, because it was running, if my change was taken into consideration, or because it was already running it was not. And let's see the code. Now when I click, well, I said sorry, where is it? This one, a test student. When I said that number 6, it just calls this delete, and if I click on this one, this is the deleted call. So it checks first if it's empty, then nothing is going to be deleted. If the head info is equal to that element, it just deletes from the head. If it's the tail, deletes from the tail, or else it needs to find it. Now to find it, it just compares this student with another student, and now it tells me that this is because it was not I was running already, so the change was not taken into consideration. Comme ça. I'm recording a video, please, later. So now to make sure that this is what it is, I'm going to run it again, and this time adds well, let's add to the head 1 and 1, and then 1 again, and then add to the tail 2 and 2, and then 2. Now if I display, what I'm going to see is this. Now if I try to, before deleting, just searching for it, it's the same thing, but let's delete. Now ID number 1, and sorry, it was not found. So now, because it compiled and run with these conditions, it's not accepting them, because it compares not only the ID. If the ID is the same for this class, now the ID is not enough to know if the two objects are the same. So if you just compare with the ID, the rest are going to be no name, it's going to be null, and then with this one has a name N1, while the other one doesn't. So it's not going to be, they're not going to be considered to be equal. So that's why it says no, I can't. So that's the that's why we had to change the way we're looking at this, just to adapt to the situation that we were doing. So now if I run this thing again, just to make sure, I add the node 1 and 1, and then 1 as a GPA, and then add to the tail 2 and 2, and then 2, and then add to the tail again 3 and 3 and 3. If I display them, I have 1, 2, 3, and if I'd like to delete one of them, let's type 6, and I'd like to delete the ID 3, it tells me, well, 3 has been deleted. And if I display them, so 1, 2 now is in the list. Yes?
He only checked for the tail, right?
For what?
In the code, we have one.
Yeah, no, what it was doing in the code, it was checking here. If the head info, just before, no, what this is doing, this is something we can just remove, and it will work. Why? Because this is just trying to avoid doing some kind of repetition. So it just checks first, is it the first one? If it's the first one, okay, fine, no need to look for it. If it's not, okay, look, is it the tail? No. Then if it's not the head or the tail, then I have to look for it. So that's the look for it is a loop that is going to go through every element, and this is what is going to happen. That's why we have a loop here. That is going to stop only if I reach the end of the list or I find it. So that's the idea. Yes?
So we don't need the head and tail deleted. We delete them.
You mean we don't need to have these? That's what I mean. These two,
Yeah.
because this code can do the same thing that this is doing.
Yeah, because we
Yeah.
have the fountain.
But this is some kind of a shortcut that is going to be maybe avoid for the head. No, the head, basically you can just remove something. This is not something that's going to be helpful. But from here, basically, you can for this one, obviously you can just you can leave it, because this can save you some time. If it's the last one, you just need to ask one question, you can find it. Well, if you don't ask this question, you're going to repeat, maybe if the list has 10, you're going to repeat 10 times. So that's the idea behind these two questions. So you can just keep them, it doesn't hurt. But so if it's the first one, you don't need to even check, because you're going to delete from head. Delete from head is going to remove the first one that is there and just make sure that it changes the head to the next head. Now the head is the head.next. So that's what is going to happen. Is that okay? So now we've done all these things. Now the fun part starts, because these were just like getting warmed up. Now we'd like to do something like this. Well, it's not that much, but what if now we'd like to add some new methods? You see this one, this length here returns the number of elements in the list. We almost did it. let's go back where I was. What? Yeah. So when I did something called print number of elements, basically I don't need to do this thing. I can just call it length because that's the name that we would like us to, they want us to do it. So I'm going to call it length, and now it's not a void, I'm going to make it int. All I need to do now, instead of displaying, I return the count. So now this is this, which is done. Now let's start from here. Let's add a method called clear that empties the list. How to do that? How to delete all?
We take delete from the head or
Public void, I'm going to make it, call it clear, right? And then what I need to do?
we take delete from tail or
So I delete one by one from the tail?
no, I need we do a loop.
We don't need even a loop. We do? Head equal to tail to equal to none. Now which means now the head and tail will remember where the list is. Just put them as none. Now the list is somewhere in the memory, but it's not accessible anymore. The garbage collector is going to take it out. But just by putting this, I'm clearing the list. I don't need to physically do it one by one, because every delete, even when I delete one, let me just check this, my favorite drawing. Yeah. Now even if I have something like this is my list. Okay, hold on. If I have something like this, let's say, and I have this 10 and then this 8, and that's it. And this one points here, and this is my head, and this is my tail, pointing to here. Now if I delete from the head, what is going to happen? Like say delete from head, this one. So if there is the list, sorry, I'm here. Is it empty? No, so why not? Now first of all, I get the head.info. Why is this? Because delete returns something, and then it's going to be returned. So that's why it returns basically what it deletes. But we don't care about returning, so we check if is it the head is equal to the tail. No, it's not the case. So we're here. The head is going to be head.next, which means now by deleting from the head, I just change this to be head.next, means here I'm pointing to this. Now in the memory the 10 still exists, but the head doesn't point to it. So after a while the garbage collector will realize that, oh, there's some kind of some object that is not being referenced, but it takes some memory for nothing. I'm going to remove it. So we did not physically remove it from the RAM. It will stay there for some time, but we just forgot about it. We just say, okay, you know, I'm not looking at this 10. It's not there. But it's still there now for some time until the garbage collector is going to take it out. So now when we have a big list, I would like to clear them all. Just say there's nothing, there's no head, there's no tail, and that's it. The list is going to be somewhere floating in the RAM, and then it's going to go when the garbage collector is going to take it out. And this is how I clear all. I don't need to take one by one and do it, because it's just going to take a lot of processing for nothing. The result is going to be the same, objects in the memory without being referenced. So that's the idea, why the clear. Just this is going to be enough. So let's go back to the clear. Yeah, and this is what we did, and that's enough. Okay, what about the next thing? Get the first. Returns the info of the first node, which is like, give me the information of the head, yeah. So get first, which, you know what, I'm going to copy this. Public t get first. So basically I'm going to return head.info, because .info is the data type of t. If I had head is a node, an SLL node, that's the data type of the L. But I don't want to return the L, I would like to return the t, the data type of that L, which is in the info. The info is the t. That's what I'm returning. And obviously get last, same, but this time with the tail. So return tail.info, and then length, we did it, and this toString to return all the nodes as a string separated by a space, which is like the print all again, but instead of displaying it, print all prints them. Now I'm going just to add them to a string, because toString returns a string. So let's do that. How can I? Well, let me just copy this then. And yes, of course, this is an override. I can just make sure to mention it here. And then what I need to do is that this print all, I don't need to do this. I'm just take this for loop, but I don't want to print it here. What I need to do is have a string. This is going to be my string s. I put it to be empty at the beginning, and then of course I changed it to be ln because I wanted to go back to the line. But now this is my string s is going to be s is equal to this, actually plus, and I'm putting a space after it. So this is, instead of displaying, I'm just storing it somewhere. And now, you know what, I'm going to call it this value to return. Now I put small s just to remember that this value is actually a string, and then what I need to do is to return s value. So what happened now is that it's basically the same processing, except that instead of displaying, I store it somewhere in a variable that is string. And you remember this, what it does, right?
Yeah.
So exactly, so this is just s value plus temp.info plus this. So, but it's a shortcut basically. So I'll take the value, but it's important for me to put this to be empty, because if I don't, this is null, and then I'm going to have a problem. Value might not have been initialized. So that's why I have to put this empty text. Notice that there's no space, it's just you open, you close. That's the empty text. And now this is going to be take the info, add a space to it, and add it to the value. And then, okay, go to the next node, take the info, put a space to it, add it to the value, and so on. At the end of this loop, this is going to contain all the elements, one next to the other, and I return it so it can be displayed. And this concludes this part over here. And now update your test student to add the option to these methods here. Let's do that. So now let's test student. We need to clear. So let's just add the case 7. Sorry, case 8. Now case 8 is going to be clear, which means I don't need to do anything but just to say list dot clear. Okay, case 9, which is going to be get me the first. So get first, I need to display the first element. For example, the first element is, and then I'm going to do this get first. Now get first is returning a student, right? So if I'd like to see it, I need to display it. Because this student has a toString, I'm going to be able to see it. And 10 is going to be like 9. Case 10, Control C, Control V. And it's the last element is get last. Okay, what else? The number of elements, probably I added it somewhere, but in the int, I think this is what I add. Oh, did I? No.
Yeah, we made.
But I don't think I have it. I'm not seeing it here.
Yeah, it wasn't
In the other one, in the double. I added it in the double, so I'm just going to add another one. Okay, case 11. The number of elements is, and then is it what? Get length. The list dot length. Okay, and the last one, is it the last one? Yes. ToString. Well, the ToString, it's like the print all. Well, I'm going to add it anyways. Okay, case 12 is out. All elements, and then another s out, and then I'm going to make this list dot nothing, because this is going to call the ToString of the list. The SLL has a ToString, so if I just call it, this is going to call the elements of the ToString. Now my quit should be updated to 13 now, and I'm going to update the rest. 12, there's no break? Okay, but it doesn't have to, because it's the last one, so it doesn't matter. So, but if you put it, it's not a problem, but I don't have to. Now let's just copy and paste. Sorry, let's copy and paste. So we have 8, 9, 10, 11, 12. So this is 7, 8, 9, 10, and 11, and 12, and 13 is the quit. Now 7 search for 8 was clear, and the other one 9 was get first. I'm just lazy typing something that is more get last, and then get length. I'm just getting lazy this time. And then the last one, ToString, and let's run. There's a problem, it seems. Cancel. What's the problem? Because I was still saving. There's something running. Okay, let's stop this and run it again. One or more projects compiled with errors. Okay, what's the error? I don't see any. This one. There's an error here. Maybe it's something. Oh, because this one now doesn't exist anymore. So it's like list elements length, and just to, because now I need to display it. No semicolon here. Okay, now let's run confidently. Inshallah, it should work. Let's just add some elements. So we 1 and 1, 1, and then let's add to the head. I don't care. 2 and 2, 2, and then you notice I'm just messing things up, but it doesn't matter. I'm putting all the values at once. It doesn't matter, right? 3. Let's do it the way you expect it to be. Let me display now this with the print all. This is the print all. Now if I'd like to display with the ToString, I'm going to use 12. This is the two strings, one next to the other with a space. Now display, no, before clear, I'm just going to display get the first, which is 9. So this is the first element, is it? That's the first. That's the last one entered, but I added to the head, so it's the first element. Now give me the last, so it's number 11 or 10. 10 gets the last, and then 12, no, 11 gets the length. I have 3 elements, and then 12 will display them in one line, and then clear is going to clear everything. If I display them with 12, there's nothing. If I ask how many, what's the length is 0, and that's, it shows me there's nothing. The list is empty. And 13 is going to quit, alhamdulillah. So that's done. A lot of fun. as you can see. But it takes some time, right? So you have to spend some time to do this correctly.